Today in Your Face Anatomy, we'll be learning about the dermis and other shit in your skin.
All right, the dermis. So with the dermis, we're going underneath the epidermis. So epidermis was our stratified squamous epithelium with all of its 5 layers, stratum corneum, etc. Underneath that, if we peel that back, we've got the dermis. And the first thing we're going to notice about the dermis is we've got these structures called dermal papillae. So these are defined as tiny nipple-like projections that poke up into the epidermis. Now, we said previously my epidermis was avascular, so it doesn't have any blood vessels going to it. So it can't get its own oxygen. It can't get rid of its waste products. It's got to have some way to get the nutrients and stuff that it needs to survive. That's where my dermal papillae come in. These little nipple-like projections poke up into the epidermis with their blood supply, and then they're able to spread the oxygen and take away the waste products and bring the nutrients to all of the tissue around each of these nipples. And there's a bunch of these nipples poking up into our epidermis. Our epidermis also functions to bind the epidermis to the underlying tissues. And we actually have 2 layers to our dermis, 2 layers to the dermis. I've got my papillary layer and I've got my reticular layer. So how we make that distinction with my papillary layer, we call it the papillary layer because that's where we're going to have our dermal papillae are going to be in that papillary layer. And so I've tried to create that for us just briefly here. So here's my epidermis. This is my 5 layers of skin. Come, let's get sunburned, etc. Blah, 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 blah. We peel that back, and here are these little nipple-like projections that are carrying gases and nutrients up into my epidermal layer. So all of this is going to be my papillary layer where we have these nipple-like projections, the dermal papillae poking up into it. Underneath that, all of this region then becomes my reticular layer. And this is where we're going to see a lot of the accessory organs come into play, hair follicles, nails, glands, a lot of that we're going to associate with that reticular layer. Then underneath that is the hypodermis or the superficial fascia. Really just depending on what you want to call it. I just prefer hypodermis. It just makes it easier for me. So dermis, 2 layers. Papillary layer is the top of my dermis. The reticular layer is the majority of it. It's 80% of my dermis. Only 20% of it then is my papillary layer. So with our dermis, we also give rise to our first set of real nerves to be familiar with. So when we're talking nerve cells, what we want to make the first distinction of is sensory versus motor. So any nerves that are carrying impulses or bringing information to my brain or my spinal cord, that is going to be sensory. Anything coming to my brain is sensory. I'm bringing information to my brain, so it's got to be sensory information about something that's going on around me. Any impulses that carry information away from my brain and spinal cord, that's going to be motor. So that's what you have to remember. Sensory, motor. Sensory to the brain, motor away from the brain. Meaning I'm going to send these impulses away from the brain to a muscle or gland that's going to have a reaction. So if I put my hand on a hot stove, I'm immediately going to get that sensory impulse going to my brain. Hey, that's hot. Move your hand. Then I'm going to send that impulse to the muscles that control my hand. Hey, move that hand. That's hot for the motor aspect. So motor, we're talking some sort of effect is happening. Typically with motor impulses, we're sending the impulse to a gland or a muscle that is going to have a reaction to the sensory information that we just sent to the brain and spinal cord. Now, I've got just a couple of specialized nerve cell processes that I want us to be familiar with. The first is called the Merkel cell. So a Merkel cell is just something that we associate with touch. When touch happens, it's going to fire off our Merkel cells. Hey, we've been touched. Then we have lamellated or Pacinian corpuscles. Lamellated or Pacinian, those are really interchangeable. I use Pacinian myself because it has a P. With our Pacinian corpuscles, they get stimulated by heavy pressure. Stimulated by heavy pressure or vibration. But I see pressure, Pacinian, and I make that association. That's how I can remember the 2. Pressure, Pacinian. Then I've got my tactile or my Meissner's corpuscles. And with these guys, they fire off for light touch. So if someone tickles you with a feather, that's going to fire off your tactile or your Meissner's corpuscles. Like if a mosquito lands on you and you get swatted before it bites you, that again is tactile or Meissner's. Anything really light touch. And then lastly, we have our free nerve endings. Free nerve endings respond to temperature change. So know the difference between sensory and motor. Sensory, motor. Know my 4 types of specialized nerve processes here. Merkel cells, lamellated, tactile, and free nerve endings, what they do, what they sense, what fires them off. And we're going to associate those with the dermis for the most part. Now, if we get underneath the dermis, we're going to roll up into the hypodermis. So the hypodermis is actually called the subcutaneous layer, just beneath the skin. That's what subcutaneous means, subcutaneous layer. Also known as the hypodermis, also known as the superficial fascia. So we've got 2 AKAs to learn, as well as the subcutaneous layer. So this is the bottom layer to my skin. It's got a couple of jobs. It helps to insulate, it helps to protect, it helps to store fat. Also connects our skin to the muscles and bones that are underneath it. But I think one of the most important things that our hypodermis does for us is it allows the skin to move smoothly over tissues / muscles that are underneath it. So our skin's just not getting bunched up by the musculature or the tissue that is beneath it. All right, so now that we've talked about the individual layers of the skin, let's talk about some of the accessory structures that we need to be familiar with. And so we're just very briefly going to touch on our hair follicles, our nails, and our glands in the system. So those are the accessory structures, hair, nails, and glands. All right, so the first one to talk about is hair follicles themselves. These are typically dead epidermal cells. They contain melanin, so they have a pigment to it. There's a color to it. There's 3 main parts to a hair follicle: the root, the shaft, and then the papilla is kind of like the anchor that holds it into place. And we have our first real muscle that we need to be familiar with moving forward. So put a little story next to that. These are my erector pili muscles. Erector pili muscles. This is just smooth muscle that attaches to each hair follicle. What does it do? It causes goosebumps. So the erector pili muscle is what makes your hair follicle stand up on end. You know, if you get nervous or scared, the hair stands up the back of your neck. That is your erector pili muscles. So let's associate those with hair because they cause goosebumps. With our nails, we have 3 major parts to a nail. Here, let's leave it for now. We've got the nail plate, which is the nail itself. So that is my nail plate. Underneath that is the bed, under the tissue that the nail plate is actually sitting on. We call the nail bed. And then the back part of it is the lunula. So the lunula is the little half moon shape at the back of my fingernail here. And that is my most active growing region. So I got the nail plate, the nail bed, and the lunula. Those are the main parts. But what we do want to look at in this picture here. So here is my nail plate itself. This orange part underneath it, that is going to be the nail bed that it sits on. And then this brown part here, that is the nail lunula. Lunula. All right, so we do have some diagnostics to talk about when it comes to fingernails. That's one thing they're going to teach you when you're checking in a patient, if you're doing a history or an examination or anything along that line. You always look at the fingernails because they'll tell you things that the patient might not. So if the patient's fingernails have a blue shade or a blue tint to it, then we're going to think we've got some kind of circulation problem going on. There's something wrong where we're not moving the gases around, and we're seeing that in our fingernails specifically. If my fingernails come back white, we're going to lean towards this patient is probably anemia. We've got some sort of deficiency in red blood cells giving us this pale or white appearance. If they come back, or if the patient presents with horizontal furrows, so what that is, I've drawn kind of a little fingernail over here. We'll get these kind of ridges or gashes going right through the middle of my fingernail. That is a horizontal furrow. We're going to think this patient had a period of prolonged illness, so they were sick for a good amount of time, or, especially with kids, this is the one you got to watch for horizontal furrows, we've got some malnutrition. Maybe this kid just isn't being treated right at home, or whatever reason, prolonged illness or malnutrition with horizontal furrows. If the patient presents and they've got red streaks cutting in their fingernails, so they could go in either direction here, we're going to think rheumatoid arthritis, RA. We're going to think ulcers or hypertension. But typically, those are the main ones that are going to cause red streaks to form in the fingernails and get rid of this horizontal furrow. So with the red streaks, a lot of time we'll have them just kind of cutting up the middle of our fingernail like so. And then lastly, are extreme curvatures. If we get our fingernails and they just curve around way too far on either side, we're going to think we've got something going on with the heart, the lung, or the liver. That's one of the big three heart, lung, and liver organs that we absolutely are vital to our survival. But if that's what we'll think with if we see the fingernails curving too much all the way around, extreme curvature. All right, and then we have our glands. So our last accessory structure, we've got two major types of glands that we need to make the distinction of. First, we've got sebaceous glands. And the big thing with sebaceous glands is they secrete sebum. So sebum is the oils that our skin releases. So what I really want to pull your attention to here, SEB for sebaceous, that's important. SEB for sebum. So my sebaceous glands secrete sebum. It's really easy to confuse sebaceous and sudoriferous, which is our next type of gland we have coming up. But if we remember, SEB sebaceous, they secrete SEB sebum or oil. That's how we'll remember that. I won't get that mixed up. So they function to one, they keep your hair and skin soft and waterproof. These oils that our body produces, they are absent on our palms and soles. We don't need those oils on our palms and soles. And acne actually results from too much sebum being secreted. It starts to clog up the pores, causing issues. So acne is an issue with overactive sebaceous glands. Our other type of gland are the sudoriferous glands. So the sudoriferous glands are really like our sweat glands, and we have 4 different types of sudoriferous glands to talk about. So the first one is, well, before I get into that, I've got eccrine, apocrine, ceruminous, and mammary. So that's the first thing we need to know about sudoriferous glands. What are the 4 different types of sudoriferous glands? Eccrine, apocrine, ceruminous, and mammary. All right, so our 4 types of sudoriferous glands or sweat glands. Our first type is the eccrine gland. So the eccrine gland is the typical sweat gland. When someone says sweat gland, you think of an eccrine gland, an eccrine sudoriferous gland to be specific, but an eccrine gland is what you think of. That is our sweat gland. It responds to body temperature that gets elevated by exercise or the outside world. It's what makes us sweat. And its fluid is always secreted in a pore. So eccrine glands are the sweat glands. Our next type is apocrine. So apocrine glands develop a scent. So you smell the way you smell because of your apocrine glands. Typically, they develop in our axillary or in the groin regions. That's why you stink. The way you stink, the way you smell, it's my apocrine glands, which are a type of sudoriferous glands. Then I got my ceruminous glands. These guys are what secrete earwax. And then I got my mammary glands. These are what secrete milk. So just make note, all of these are exocrine glands because they secrete products to the outside world. So when I say my 4 types of sudoriferous glands, that sudoriferous glands are 100% exocrine. Know each of these glands and what they do. So, since we're talking about sweat glands and elevated body temperature, let's talk about how we control that. We have to be able to get rid of heat. Every time we move a muscle, heat gets released as a waste product. And so if we don't address that, we could be in trouble really fast. So we have 4 major ways to control heat loss. So that's the first thing we want to know. What are my 4 ways to control heat loss or prevention? We got radiation, conduction, convection, and evaporation. Those are my 4 types. Radiation first. This is the primary means of heat loss. This is the way our body controls heat loss most of the time. The primary means of heat loss, radiation. So this is where heat moves from warm surfaces to cooler surroundings. This is your body kind of emanating heat. You can feel this specifically when you like walk in the summertime. You come inside from the outside where it's hot into an air-conditioned room, and how that feels. You're like, oh, that feels so good, because we start to lose all of that excess heat that our body is building up. The next way our body controls heat is through conduction. So conduction, heat moves directly into cooler objects that are in touch with it. So if somebody's running a fever, we put that cool washcloth on their forehead to help pull out some of that heat, to deal with that, help cool them down a little bit. I always remember conduction when you sit down on the toilet seat in wintertime for that first time, and first thing in the morning, like, oh, I'm awake. Conduction. The heat is moving from your bum into the toilet seat. We're getting rid of that excess heat. Then we've got convection. So with convection, this is a continuous circulation of air. So this is like standing in front of a fan that is moving to help get rid of that heat. Convection ovens cook by circulating air, hot air specifically around your food to cook it. So it's the same kind of concept. I would think more of like a fan, a box fan or something that spins, and you feel, that is more going to be along the lines of convection. And lastly is evaporation. So with evaporation, fluid changes from a liquid to a gas, carries those high energy electrons that are producing some of that heat away with them, specifically when they can overcome the hydrogen bonds that are holding them together. So evaporation, fluid changing from a liquid to a gas, takes the heat away with it. Those are my 4 primary ways to control heat loss. Let's make sure we know what they are first, and then let's make sure we know what each of them. All right, inflammation is a normal process. Inflammation is your body's attempt to stop the spread of any damaging microbes or pathogens, anything that's just not supposed to be there. And it's one of your body's defenses. So we have 4 characteristic signs to inflammation. First, we get a reddening, then we get some swelling, we get some warmth, and it becomes painful. So red, swollen, warm, and painful. Those are my 4 characteristic signs of inflammation. Let's make sure that we're familiar with that. And we just need to understand that inflammation is a normal body process. And then we have burns. So burns, of course, if the epidermis, or if your skin gets damaged, I should say, burns can be a result of that. So we divide our burns by degree. So a first degree burn, this is going to be like a bad sunburn. We get a reddening to the skin, and it's very painful to the touch. So with this layer, it really, we've just damaged the epidermis with a first degree burn. Now a second degree burn, we have damaged the epidermis and the dermis. So this is like a really bad sunburn where we get the reddening and we get blisters. So blisters make an appearance with a second degree burn. And then a third degree burn, we get a deep charring to the skin. With a third degree burn, we've damaged the epidermis and the dermis and the accessory structures, and even down into the hypodermis with a third degree burn. So let's know with each layer what happens with the first degree burn and what levels are affected. Same thing with a second and a third degree burn. So we're familiar with that on the practical exam. All right, good luck.